okay, of C2, oops, HC2H3O2. If I had 5 grams of that stuff, okay, 5 grams of that stuff, to 1 liter of water, what will the molarity of the solution be? Okay? So we're adding some of a chemical into some water. And when you add a chemical into water, what do we call that? Well, it's a solution. A solution. That's a new word that you probably heard and maybe even, I don't know, used yourself. Has anybody ever said solution?
Yep.
All right, solution. A solution in chemistry is not just the answer. A solution is also when you take a chemical and dissolve it into another chemical. All right? So we're going to answer this question. We're going to answer this question. What is our first step to answer the question? The equal sign. Very good. And then a line. All right. Now, I was breathing out. All right. So, what goes on the right side of the equal sign?
Molar HC2H3O2.
That's right. Molarity. Molarity. So what does that big M mean? What does molar mean? What does molarity mean?
Moles over liters.
Moles per liter. That's right. So right here I'm going to put moles of C2H3O2, HC2O3O2, per liter of solution. Okay? There we go. What goes over here?
5 grams.
5 grams. 5 grams, that's right. 5 grams of HC2, H3O2. All right, what do I have to do next?
He's doing his puzzle. We have to, well, since you want moles, if the gas aren't really because it's not polarity, you have to convert it.
You'll have to have moles and liters to get molarity.
That's right, I
As
need
your
moles and
final
liters
thing.
in the final thing, that's right.
But you have grams right
I have
now.
grams right now.
So you need to write grams to cancel that out.
Wait,
Grams down here, right?
Yeah.
What is what?
The 2 lines.
Right
I
here?
think it's going to be grams per mole right there.
Where, this?
No, in the,
This?
yeah.
It says moles of H2CH3O2. That's a high P.
Oh.
So down here I need to have grams of HC2H3O2.
I think it's grams per mole.
But then you'll have mole and liters somewhere.
Okay.
You'll have moles and liters.
Can I put moles up here? Do I know anything about the relationship between
Yes,
moles of this
60
stuff
grams
and
per
grams?
mole.
That's right, I do, right? I know that there's 60 grams of that stuff for every 1 mole. Now, how do we know it's 60?
You did the math.
Right. All right, now I'm in the land of the what?
Moles.
Land of the moles.
Now we need to
But I
get
want
to
to stay
liters.
there, right?
We have moles right now, but we need liters.
Right, so where do we need the liters?
Right below. That.
We need to get to moles and liters and then to get back to moles.
We need liters on the bottom, correct?
Mm-hmm.
So I can just put liters on the bottom. How many liters is this solution going to be?
1.
1 liter. 1 liter. There it is. So 50 divided by 6 times 1. All right, calculadoras.
Wait, 50 divided by 60?
5 divided by 60. Who's my calculadoras? All right.
What is it?
5 divided by 60. Okay. 0.083. Correct? And now look at this. Do you remember?
Wait, what?
Oh, no. I made a mistake here. This is supposed to be not 1 liter, but 0.1 liters. 0.1 liters.
So you need, all you need to do is add a 0 to that in front of it.
That's right.
Behind the decimal.
That's right. Well, so now we do 5 divided by 60 divided by 0.1. So
So it's
0.833.
Yeah, it's 0.0.
No?
Oh, yeah.
Wait, 5 divided by 60.
5 divided by 60 divided by 0.1.
You 8 3 3 3 you 8 3 3 3
5 divided by 60 divided by 0.1.
It's 2-1. It's like the whole game is on.
Okay, so do you remember the other day when I had that bottle of vinegar?
Yeah.
What did it say? Who read it? It was Sam that read it, I thought. Or was it Colin?
It was Colin. It was 5%.
So now Australia.
It said 5%. 5%.
Third place team.
Now 5%,
Wasn't he second place?
shh, you have all day to do something else, to talk about other things. All I'm asking is 15 minutes to concentrate on this. And now we're down to how many minutes, Sam, left?
9.
9 minutes left. So we got 9 more minutes to concentrate on this. And then we focus on other things the rest of the day. Don't think about chemistry the rest of the day, okay? All right. 5% means 5 grams out of every 100 milliliters of solution. And 0.1 liters is 100 milliliters. So this is the concentration of the acid in the vinegar. Do you see that? We just found out the concentration of the acid in the vinegar
Yes.
because the 5% means 5 grams.
Woohoo, we got it.
Okay? So now, look what we can do. We can answer the question that we've been after all this time, which is, now I'm going to erase this part. I'm going to leave this. That's the concentration of the vinegar. Because what we've been wanting to know is how many grams of sodium carbonate to how many liters of this stuff. Right? So let's say if I weigh out 1 gram of
A2CO3.
Na2CO3. If I have 1 gram of that stuff,
You need 0.83
how many
grams of
how many liters of HC2H? Whoops. How many liters of 0.83 molar HC2H3O2 do I need? And that's the question we've been after all this time, right? Because now we can do the experiment, right?
once we finish this.
After we finish this question, because for every gram we weigh out, we'll know how many milliliters of this H2C3H3O2 we need. Okay? Because we know its concentration is 0.83 molar. Does that make sense?
Yeah.
All right. What do we need to do to answer this question? Equal side. Breathe out. What units are we looking for?
Liters of HC2H.
So we are looking for molarity.
I don't know. What's it say? Read the question. You got to read the question. Be a detective to answer this. What we're after.
Liters of HC2H3O2.
That's right. How many liters of this 0.83 molar stuff? So, liters of HC2H3O2. All right? How many liters of that stuff? What do we start with over here?
1 gram of HC2.
1 gram.
1 gram of
Na2CO.
Na2CO3.
And we need to cancel that out. We don't need it.
Okay? So we need to get rid of grams, correct?
Grams of Na2CO3.
Grams of Na2CO3. Pay attention, everybody. Pay close attention to this.
So on the bottom we put 1 gram of Na2CO3.
That's right. We put grams of Na2CO3. Now, what are we trying to convert those grams to?
Liters of HC2.
Liters.
Or we could do more.
Liters.
Do we know how many liters there are per gram? That's what we're after. We don't know that, though, right?
So I think I have to go.
I think we need to get to the land of the moles. There's another reason we have to go to the land of the moles. Because, listen up closely to this, alright? It's not a 1 gram of this to 1 gram of this ratio, is it?
1 gram of this to 0.83
It's 1 mole
grams.
of this to 1 mole.
It's 1 mole of this to what? 2 moles of this. Remember that equation that we wrote long time ago? That's alright, we can leave right there. Alright? So, we need to go to the land of the moles to get the power of the equation. You guys remember the equation?
And it's like, it's 2 H2 combining with
Does everybody remember that, or should we rewrite it down at the very bottom down there? Or I can rewrite it right here. Right, we're going to rewrite the equation. Here it is, ready? Na2CO3 plus HC2H3O2 creates H2CO3 and NaC2H3O2. There's our equation, and then we see that it's not balanced, and so we would have to go back and forth and figure out how to balance it, and then we would see that this is the balanced form of the equation. So yes, 2 moles of this for every 1 mole of that.
Yeah.
Okay? That's what we had before. We did that lots of times before. So, now we need to go from grams to what? Moles.
1 mole. 1 mole is 106 grams. I remember that.
106 grams for every 1 mole. You guys remember that part?
Yeah.
Ladies on the couch, you guys remember that part? Each mole of this stuff weighs 106 grams, right? And now what can we do?
Well, you have moles right now.
Moles
You
of
want
sodium
liters.
carbonate.
Oh, so you can put 1 mole of NaCO3 for every 2 moles of HCl.
Yeah, I need to convert this to HC2H3O2, right?
Liters.
I need to get to
For
moles
every
of that.
liter.
No, but then
So I need to go moles of Na2CO3 to every 2 moles of H2H3O2.
You put H2C2. That's HC2.
There we go. So we're in moles of acetic acid.
Now you have to get into
Now I have to get to liters. How can I get to liters?
Of
So
HC2.
you have to put moles of HC2.
On the bottom, that's right. Moles has to go down here.
And then you'll have to put on the top
0.83
liters?
Liters
Oh,
of that stuff.
Yeah, but I think it's 0.83 liters.
It is. It's 0.83. So where does that 0.83 go?
5 liters.
It's because there's 0.83 liters for every mole.
No, oops. 0.83 moles.
So 0.83 moles for every 1 liter. Got it? Are we in the units we want now?
Yes.
Are you sure? We're done?
Yes.
Okay, so somebody with the calculator Dora, do it for us.
1 divided by 106.
Divided by 106 times 2 divided by 0.83.
Divided by what?
Times
1
2.
divided by
I got it.
divided by 106.
It's not the times 2.
Divided by 0. I got it. 0.0227.
0.23? 0.23?
Yeah, 0. What? No.
0.02273.
That's
0.027,
That's rounded.
which rounds up to 0.023. Correct? So what does that tell us? What does that tell us?
That you have 0.023 liters of that stuff
For every what?
for every mole.
1 gram for every gram.
Every gram.
That's right, for every gram of this stuff. So, if I bring a balance next class, we can weigh out a gram of this stuff. Correct? And then how much vinegar should we add?
0.023.
We're gonna do the balloon thing.
Liters. That's right, which
Are we
is
gonna do
also,
the balloon thing?
yes, this is 0.023 because now we know how much to add. Right? 0.023 is also 23 milliliters. Okay? So if we have a little thing, we can measure out 23 milliliters, and we know in the balloon we have to put a gram of sodium carbonate. What if I use 2 grams of sodium carbonate? How many milliliters should I use then? 46, twice as much. We've done it! We've figured out the ratio for our chemistry experiment that we're going to perform.
So is it going to show you?
Now, what happens if I put 1 gram of this and 46 milliliters of this stuff?
It won't. Though I still have 23 unreacted.
Yeah.
That's right. What if I put in 2 grams of this and 23 of this?
You'll have 1 gram of non-reacted
Now,
vinegar.
after the reaction occurs, the balloon blows up, right?
Yeah.
Who will be a larger balloon? 1 gram of this and 46 of this? Or 2 grams of this and 23 of this? Who will have the larger balloon? They'll be the same. That's right, they'll be the same. Who will be a larger balloon? 1 gram of this and 46 of this? Or 2 grams of this and 46 of this?
2 grams.
It should be how much larger?
Twice
Twice as large.
No.
What time is it, Sam? Time?
816.
Okay. So, next class, you guys have to remember these numbers. 23 mils for every gram. Okay? And next class, we'll be weighing out, we'll need to work together because I can't bring a ton of balances over here, okay? Or should we just meet at the lab?
No.
Meet here and go to
Meet at the lab. Meet at the lab at 9.
No.
Or we can come here and then go to the lab.
I'm afraid that people won't get to the lab and they might forget closed-toed shoes and it might be kind of wild and crazy. We'll go
Go to the
here.
lab.
We'll go here and we'll circle around the table and we'll have some balances and we'll take turns rotating around. Balance, okay?
23 grams per
23 milliliters
David,
of
I can move what's here.
acetic acid for every 1 gram of
No, the
sodium bicarbonate. Sodium carbonate.
8.7.
All right, bye-bye.
Bye.